So in this video, we're going to be looking at what's called absolute value equations. So in order to solve absolute value equations, we need to look at some key objectives when trying to solve an absolute value equation. So we may be faced with an equation that looks something like this, in the form of the absolute value of C is equal to, let's say, D. Well, when dealing with an absolute value equation, we will need to rewrite this as C is equal to D, right? I've rewritten it the first way, the same way as I've seen it above without the absolute value bars. And then I'll state that or C is equal to negative D. So you rewrite it the first way you see it without the absolute value bars, and then you rewrite it again. However, that value that it's equal to has to be its negative value. Another thing we need to be aware of, there are times when we may have absolute value bars on both sides of the equation. So maybe I'll have, let's say again, C is equal to the absolute value of A plus B, right? So this is a little bit different from above, but it's okay. We start off the same way. First, I write C is equal to A plus B, insert the or, and C is equal to the negative of the quantity of A plus B. So again, I have to write it over the first way without the absolute value bars. And then the second way, I'll take the negative of the quantity that's within the absolute value bars. And of course, you know that after that, you'll have to distribute the negative times each term inside of that quantity. So it'll make more sense once we apply it to some actual problems. So let's do that. So our first example is the absolute value of 3x is equal to 9. All right, based on what I said earlier, we would have to write 3x is equal to 9 or 3x is equal to negative 9, right? Rewriting it the first way, the way we see it, but of course without the absolute value bars. And then the second way with the value on the right being negative. And after such, we go ahead and solve the 3x equals 9 just by how we solve simple linear equations. So divide both sides by 3. 9 divided by 3 is 3. Or here, divide both sides by 3 again, right? 3x divided by 3, negative 9 divided by 3, and x is equal to negative 3. So our answers are positive 3 and negative 3. If you go and take a look in the check, you would plug in a 3 times 3 is 9. The absolute value of 9 is 9. A negative 3 times a positive 3 is negative 9. The absolute value of negative 9 is still positive 9, right? Because as you recall, absolute value really means the distance from 0 on a number line. Let's take a look at another example. Here we have the absolute value of negative 4 plus 5x is equal to 16. So once again, it fits that first situation that I showed us. Negative 4 plus 5x equals 16. Inserting or, negative 4 plus 5x equals negative 16. So we rewrite it the first way exactly how it's seen without the absolute value bars. The second way, we insert a negative in that second value to the right of the equal sign. After that, we just go ahead and solve the linear equations. So it looks like we have to add 4 to both sides to get the 5x by itself. And then it looks like we have to divide both sides by 5. And then dividing by 5, we get 4. On this side, we need to get the 5x by itself, so we'll add 4 to both sides. And we get 5x is equal to negative 12. We divide both sides by 5. X here is equal to negative 12 fifths. So our answers are 4 and negative 12/5. All right, let's take a look at another. In this example, we have v plus 8, and the absolute value of that, minus 5 is equal to 2. So here, there's a small step that we need to take care of first. We see this negative 5. We can't have anything in front of or after the absolute value symbol in order to perform what we've been doing. We need to move this negative 5 over. So we do its opposite. We add 5 to both sides. So once we do that, we have the absolute value of v plus 8 is equal to 7. And now that looks much better, right? Because there's nothing in front of the absolute value. And when I say in front of, nothing to the left of it, and nothing to the right of it. Nothing being added or subtracted in front of it or behind it, or multiplied or even divided by, or into, I'm sorry, the v plus 8 and its absolute value. So nothing in front of it or behind it. So now we can go ahead and apply what we've been doing. So now we can say v plus 8 equals 7, or v plus 8 equals negative 7. And again, that's all because nothing's in front of it or behind it. We got rid of that 5. So now it's just a simple linear equation on both sides. We subtract 8. So we get v is equal to negative 1. Or here, subtract 8. And we get v is equal to negative 15. So those are our two answers. Negative 1 and negative 15. All right, our next example looks like this. 3 times the absolute value of negative 8x plus 8 is equal to 80. All right, so now I look at this and I say to myself, I have the absolute value of negative 8x. However, there's a 3 in front being multiplied times the 3, right? And then there's a positive 8. We're adding an 8 to this absolute value. We're multiplying a 3 times this absolute value. Well, we don't want any of those two things there. So I'm going to go ahead and get rid of this positive 8 and then get rid of that 3. So to get rid of it, I do its inverse. I subtract 8. So I have 3 times the absolute value of 8x equals 80 minus 8. It's going to be 72. So I moved that 8 out of there, so that's cleaning it up a little bit, but there's still that 3 in front. And remember, we don't want anything behind the absolute value or in front of it, but we have the 3 there. So the 3 is being multiplied times the absolute value of negative 8x. So we do the inverse operation and divide. So when we divide, we get the absolute value of negative 8x, because those 3's will go into each other, is equal to, and then 3 into the 72. All right, that looks to be 24. All right, so next what we do is go ahead and rewrite it the two different ways. Negative 8x equals 24, or negative 8x equals the negative of the 24. All right, now it looks like all we need to do is go ahead and divide both sides by negative 8 to get the x by itself. So here x is equal to negative 3 dividing by negative 8 here. It looks like that x is equal to positive 3. All right, and that all started because we wanted to get rid of what was in front of or after the absolute value symbol, and then we applied what we learned. I'm going to attempt maybe one more here. So our problem is the absolute value of 3x plus 3 equals the absolute value of 2x plus 5. So you see how this one is a little bit different because there's absolute values on both sides of the equal sign this time. But no worries, that was that second situation that I talked about at the beginning of this lecture, right? And I said that we would write the first one over exactly how we see it. 3x plus 3 equals 2x plus 5, without the absolute value bars, of course. And then the second way, we'll write 3x plus 3 without the absolute value bars equals, and then remember I said we needed to take the negative of the quantity of that second absolute value. So the negative of the quantity of 2x plus 5. And that's all we need to do. And now we go ahead and solve these. So I want to get the x's on one side, so I'll subtract 2x from both sides, and I get x plus 3 equals 5. Here I subtract 3, so I get x is equal to 2. All right, on this side, it's important to know that we go ahead and distribute that negative value times everything inside of the parentheses. So thus we get 3x plus 3 equals a negative 1 times 2x is a negative 2x. A negative 1 times positive 5 is a negative 5. And now we go ahead and solve it the way we know. So we're going to add 2x to both sides. So then that'll get us 5x plus 3 equals negative 5. We need to get the 5x by itself, so I'll subtract 3 from both sides. So we get 5x is equal to negative 8. And now between 5 and x is multiplication, so I do the opposite, which is division. What we do to one side, we must do to the other side. So now x is equal to negative 8/5. So our answer is x equals 2, or x equals negative 8/5 for this absolute value equation. So remember the two different ways that we have to look at it in solving absolute value equations, when the absolute value is on one side or on both sides of the equal sign. I hope this helped. Please feel free to share and send it to others that may help. And also go ahead and hit the like button and subscribe. Take care and have a nice day.